Hello everyone, my name is Kasha Alvin Sali, and we're doing machine learning project called generative attention-based mechanisms for fake currency note detection. And we came up with the most ideal model that we'll deploy, and I'll be taking you through the first parts of this presentation covering the machine learning operations, and then of course the deployment. And then my fellow colleague will come in later to talk about the remaining part. So first of all, we started off by establishing a virtual environment on our local machine, that's the PC on VS Code. Then the next step was for creating the first API key to the back end. Then after that, running it onto the terminal, and then generating the user interface using Flask. So we started off with model training and saving. Using our data state, we're able to understand and come up with these features that will be used to distinguish or classify images depending on whether they're actually fake or real currency notes. Then after that, we normalized and preprocessed the data. And the very same data we used, we developed models. At least there were like 10 models, but depending on the evaluation scores we had come up with, we decided to go the random forest algorithm just because of its robustness and then ability to handle some high dimensional data. Then after that, we trained the model on the very training data set, and we tuned the hyperparameters here and there just to come up with a good validation and training accuracy. And then after that, we evaluated the model's performance using different test data set just to make sure that the model actually generalizes well to unseen data. And after that, we're able to save the model. And then it came to the part of deployment using the saved model. Of course, we applied PyTorch, and then we had to come up with a serialization for the very saved model. Then after that, we had to integrate first KPI, as I earlier said, just to have a user interface that will allow the users to upload images. And then we hosted the app on Render. There are very many hosting sites such as Heroku, but we chose Render just because it had ease on formatting and then coming up with a user interface and then also uploading some of these CSV files and display. Then also applied the cross-origin resource sharing just to allow user requests from, when you're accessing the very same hosted platform, but you're using other domains. Thank you very much.
Good evening once again. My name is Kawagere Salim and I'm here to represent Group 9. But specifically now I'll be talking about the MLOPs, which are machine learning operations. My group member has already talked about the first slides. From the introduction to the virtual environment to the model training and saving. I'll begin from the model deployment. The model deployment, I'll just be talking about how I deployed our model specifically, using first API and then finally deploying it on Render, whereby it's currently running right now. So, of course, from the EDA, exposure data analysis to the pre-processing and all that, you come up with a model that is fine-tuned, that is okay, and that is prepared to work with the data set that you have. So we began our implementations from Colab, and then of course for the case of deploying on Render, it required our code to be running on the local machine. So we downloaded all the Colab files as Python files, put them on our local machine, installed PyTorch, because we realized TensorFlow was going to give us hard time because of the compatibility issues between TensorFlow and the Python versions, because TensorFlow uses deprecated or obsolete versions of Python. And it so happens that most of the dependencies of TensorFlow you download are not compatible with the current version of Python you're using. So with that said, we had to, use PyTorch because for it at least it's modern, it can easily be compatible with the Python versions. And then after that we had to write our code. We got our model, saved our model using PyTorch for serialization. And then after that, we had to integrate after saving our model, it was saved, and then we had to create an app.py. That's a Python file that was handling the API, the Flask API. So in that code, of course, you first load the dataset, the model you've saved. Then after loading it, you give it the routes to render to the page to render to the pages that will be directing to your site. And then after that, you also have to implement the cores, which are cross origin resource sharing, because these ones are how they help your system to be running from various domains or various systems. For example, it can be running on my machine when actual sense is not running on your phone. So to handle all that, we bring in this sense of cross origin resource sharing. And then after that, we have to host it. Hosting it was hosted on Render. And hosting on Render, of course, Render uses Python versions from 3.7 up to 3.11. So you have to make sure your machine is having that version of Python in that range. Then from there, you have to link it with your GitHub. Of course, our code was pushed to GitHub. You'll just link your GitHub to Render. You link Render and GitHub. You just connect your repo and Render will do everything for you. So the first API was used as a backend framework to serve predictions via an API. It was defined the request body schema, and then we loaded a training model, like I'd said, implemented the inference logic using the neural networks. We used the neural networks to implement the logic for the API. And then we created routes to render to the pages, like I said. In this sense, we also created a UI for our system. Of course, you put your index.html in the templates, and also call it from the app.py, which is our Python file that is handling the first API. So from there, you do the render template, you import that library, and that library will be the one that imports that renders that HTML file, the index.html that we just created in your templates folder. So from there, we created an endpoint to return predictions. We had from our UI, we had a predictions button. So once you click that button, it gives the predictions, whether the image is fake or real, and the confidence limit which it is basing on to give you the predictions. Then deploy the first API. We first, of course, we install the first API. Like people install Flask. We use Flask for this case. Then you use UVCon and GunCon for the serialization and cross referencing. Also implemented the first API for the predictions. Then how do you run the server? You had to run the server to first test if our app is actually running. Of course, before deploy, you have to first test if your app is running. That's why we had to run the server using the Flask. Then you test it with Postman. Postman will give you something sort of JSON files. So if you test it and give you the JSON files, depending on what you've given it, then just know your app is running and it's good to go. Then from there, I have to deploy the app, the API with Render. Like I said, just link the two, the GitHub and Render. You just connect them and Render will do everything for you. Then you just deploy, and your thing will be online to go. It'll be good to go and be online. So that said, that's the end of my presentation. I mean, Kawagesa Limu, part of Group 9. Thank you very much.